very first Cyber conference I attended was in 2009, and I met an historian who was using supercomputers to rerun simulations of battles in the Second World War, answering thorny ethical questions. Was it right to drop the atomic bomb on Hiroshima? You don't normally run into historians at supercomputing conferences. That's the flavor of what we have here in Banff, and bringing all those people together. The presentations are great, but the conversations in the hallways and outside the meeting rooms is really what adds the value. The theme of the conference is leadership in big data, in the age of big data, and a lot of what we have to do is say, not just what can we do, because the possibilities are multiplying at an incredible rate every year. What should we be doing? How should we handle this?
A few weeks ago at Stanford, researchers just built a system that allows viruses to do cell-to-cell communication in a controlled way. In other words, they call this not Wi-Fi, Bi-Fi, biological transmission. They can send up to 40 KB of data.
DNA sequencing, which is the reading of DNA, has been a decades-long international project to get faster and cheaper. We read the first human genome in 10 years between 1990 and 2000. The technologies continued to improve. So it was about $3 billion to do the first genome. Now we can do a human genome for about $1,000, and that price will continue to drop very quickly. It gives us a tremendous look into our code base, essentially. We can look at the human genome as a recipe for how to make a human. As we start to sequence millions of people, we start to understand the code just through comparison. We're doing that not just for humans, we're doing that for every living thing on the planet. Plants, animals, bacteria, viruses, anything that's alive. What it does is it generates a massive amount of data that we have to analyze and understand. When we sequence something, we're really getting raw data, so turning that into knowledge is where most of the effort is going these days. That means a lot of computational horsepower, a lot of researchers analyzing, and a lot of new algorithms looking for patterns and trends.
Big data is coming at us in every form, whether it's the microbiology that Andrew Hessel talked about in the keynote this morning, or the astrophysics data sets, or just the everyday data that you and I generate by doing things like this right now. We're producing streaming video, and streaming video consumed by folks like somebody at home ordering their Netflix subscription. Those are stretching our bandwidth requirements all over the place. Data is coming from all sorts of sources.